Hi there, we should be finishing off the review for the Algebra 2 Unit 1 test review. Looking at problems 20, 21, and 22. And this is as hard as it gets on the test. Doing the ones with the absolute values and inequalities. So combining the two things. Now this is key here. We are combining the two things. So if you remember, we just did the absolute value problems. In the absolute value problems, you have two cases. Now, to set it up as far as the inequalities go, we're going to write it out once, the exact same it's written, basically dropping the absolute value signs. So, we have the 3 plus x is less than or equal to 4. Now, for our second case, just like we did when we were solving, still the 3 plus x, we're going to switch the 4 to a negative 4. Now, if you remember, when we switch signs, divide by a negative, multiply by a negative, on the inequalities, we need to switch the direction of the inequality. Now, as far as solving goes, these aren't too bad. First one, we're just going to subtract 3. We should end up with x is less than or equal to 1. Repeating steps, subtract 3 here. And we should get x is greater than or equal to negative 7. Now, when we have the absolute value on the left, that's a less than or equal to equation. That works out so that we typically end up with AND cases. If you're not sure, take a look as we graph. On the left, we have x is less than or equal to 1, so less than or equal to, the equal to part means we got a closed circle. We should be going to the left here. On the right, we got x is greater than or equal to negative 7, so we find the negative 7, the equal to part, closed circle. This time we're going to the right. And sure enough, we're looking at an overlap case. So it does work out like an AND. So algebraically, we can either leave it as the x is less than or equal to 1 and x is greater than or equal to the negative 7. Or we can write it as the compound inequality, where the x is less than or equal to 1, and it's greater than or equal to the negative 7. The algebra version definitely points out that the x is between negative 7 and 1. On the next problem, you may notice right off the bat, the absolute value is not by itself because it's being followed by the minus 5. Really wish there was a little more space between the equation and the number line, so this time I'm going to get away with putting plus 5 above for both of them. We do that, so we got the absolute value of x plus 5. And then the 9 plus 5 should give us 14. Now that we have the absolute value by itself, we set up our two cases. So the first one is the same, just dropping the absolute value sign, so we'll have x plus 5 is greater than 14. For the second case, we got the x plus 5. We switch the 14 to a negative 14, and we switch the sign there. We switch the direction of the inequality. Solving. Subtract the 5. So we should get x is greater than 9 on the left. On the right, after we subtract the 5, we should get x is less than negative 19. Now, since when we worked it out this time, the absolute value is greater than the answer. Typically, these work out to be ORs. If we take a look at the graph as we do this, you'll see that is the case. Now, some funky stuff here with the graph. We've got x is greater than 9. Notice if we look at the number line, it's spaced, each space is going by 2. So we got 8, the missing space was a 10, and the 12, so it means 9 is halfway between that. So I'm going to approximate that. Going with an open circle, and we're going to go to the right. The answer on the right, the x is less than 19. So we got the negative 20, the other line there is negative 18, so negative 19 is in between those two. And this one going to the left. Sure enough, it looks like the whiskers, it looks like our OR case. Last one is to be quite fun. First of all, once we got that negative 9 out front, to get rid of that negative 9 that's being multiplied by the absolute value, we're going to have to divide. Now, if you remember, whenever we divide by a negative number, direction of the inequality switches. Negative 72 divided by negative 9 should give us positive 8. So we set up our two cases. First one, dropping the absolute value signs. Second one, switch the direction of equality. All right, as far as solving, on the left, we'll subtract the 1. Divide by the negative 7. Once again, hopefully everybody's paying attention because we're dividing by a negative again. So the direction of the inequality is going to change yet again. So we're going to end up with x is greater than or equal to negative 1. Repeating steps on the right, subtract the 1. Dividing by that negative again. So we'll switch the direction of inequality, and we'll end up with 9/7. As far as graphing, this one, a little on the tough side. All right. Did end up with less than or equal to, so we're kind of expecting an and here. So we got the x is greater than or equal to negative 1 on the left, so we got the negative 1, and we're going to be going to the right. Answer on the right, the x is less than or equal to the 9/7. 9/7 works out to 1 2/7, so we're going to have to approximate that. And in this case, we're going to the left, filling in the middle, so definitely the overlap. So if we're going to write this out as a compound inequality, see that negative 1 is less than or equal to x, which is less than or equal to the 9/7, or x is between negative 1 and 9/7. Hope the videos have helped with your review. Good luck on the test.